from RCDCS 1433A conducting a group project video presentation, which is statistics and probability. Okay, here's my group members. The first one is Nur Hazita binti Nazihan, and the second is me, Nur Amira binti Zaidi, and the third is Nur Ali Istina binti Hazra Hafiz, and lastly is Nur Shafina Zila binti Nasruddin.
Now I'm going to talk about our objective of the experiment. So first is to record the process outcome of MLBB, Roblox and PUBG that can be chosen. Second is to calculate the probability of getting MLBB, Roblox and PUBG from randomly spin the wheel 30 times. And then it is to know the difference between experiment probability and theoretical probability. And the last one is to find mean equals to AX and variance equals to EX squared by using the formula that has been studied.
For our significance of the experiment show that this experiment is important because it helps us understand probability more clearly and how it is applied in our daily life situations. By using a survey involving people who play e-sport games, we can evaluate the probability of getting MLBB, Roblox, or PUBG as the outcome. From this, we can learn how experimental probability based on actual data can be different from theoretical probability, which is based on what we expect to happen. By comparing both results, we can see whether the experiment supports the theory or whether there are differences due to randomness and sample size.
Okay, now I'm going to talk about the methodology of our experiment. First, we survey from the Google form. Second, from the Google form result, we put it in the spin the wheel. The third step is we spin the wheel, and after that we record the result of spin the wheel. Step 3 and step 4 are repeated again until we get 30 results. And then we record all the results, and lastly we calculate the probability of the result by using the formula.
So, as you can see, for our result, the result of our experiment show that PUBG appears 6 times, Roblox appears 7 times, and MLBB appears 17 times, indicating that MLBB was the most frequently selected outcome during the 13 times spin by the wheel.
For this experiment, the table shows the result. We spin the wheel 30 times and recorded the outcomes for 3 games, which is PUBG, Roblox and MLBB. From the results, we get the PUBG appeared 6 times while Roblox appeared 7 times and MLBB appeared 17 times. To find the experimental probabilities, we divided each frequency by the total number of spins. So, the experimental probability of getting PUBG is 6 over 30, which is we can simplify it into the 1 over 5. While the experimental probability of getting Roblox is 7 over 30, and lastly, the experimental probability of getting MLBB is 17 over 30. Next, we compare this with the theoretical probabilities. Since the wheel has 3 equal sections, each game should theoretically have the same probability of 1 out of 3, which is about 33.33%. However, from our survey data, the theoretical probabilities were slightly different, which is PUBG was 7 over 30, or we get the answer 23.33%, while Roblox was 7 over 32, and we get the answer same as a PUBG, which is 23.33%. And lastly, MLBB was 16/30, or we get the answer 53.34%. Finally, we look up the differences between the experimental and the theoretical probabilities. These differences show how our actual results vary from what we expected in theory, which can happen due to change or randomness in a small number of trials. Next, we calculated the differences between the experimental probabilities and the theoretical probabilities. For PUBG, the experimental probabilities was 6/30, while the theoretical probability was 7/30. When we subtract them into the 6/30 minus 7/30, we get the negative 1/30. When we get the answer negative 1/30, we times it with 100%, which is equal to negative 3.33%. This means the experimental result for PUBG was 3.33% lower than we expected. Next, for Roblox, both the experimental and theoretical probabilities were the same, which is 7/30. So when we subtract them into the formula, that is 7/30 minus 7/30. When we get the answer, we times it with 100%, we get the answer is 0%, which is experimental and theoretical probability differences is totally 0. This means the experimental result for Roblox match the theoretical probability exactly. Lastly, for MLBB, the experimental probability was 17/30 and the theoretical probability was 16/30. When we subtract them into the formula, 70/30 minus the 16/30, we get the 1/30, and then we times it with 100%, and we got the answer is 3.33%. This means MLBB appeared 3.33% more often than the theoretical expectation. For overall calculation that we calculated, PUBG was slightly below the expectation value. Roblox matched it perfectly, and while MLBB was slightly above the expected value.
So lastly is the conclusion. In this experiment, our group conducted 30 spins on the eSport games wheel and recorded the outcomes of PUBG, MLBB and Roblox. We found out that the MLBB appeared the most frequently, followed by Roblox and PUBG. From the results, we calculated the experimental probabilities and compared them with the theoretical probabilities. Throughout this activity, we gained a better understanding of probability concepts and learn how to conduct the experiment properly. And we also would like to thank Madam Nur Azrani binti Muhammad Nur for her guidance and support throughout this assignment.
Now, here is the question for set 2, which is given by the Madam Azrani. Okay, for question A, to find the expected value, we use the standard formula for a continuous random variable, which is the formula is EX will equal to integral of negative infinite to infinite x times with fx dx. So, in this question, we will given by the probability is EX equal to integral of 0 to 5x times 3/50 times x squared minus 4x plus 5 dx. So, the integral only needs to be evaluated from 0 to 5. Next, the constant of 3/50 is taken out of the integral. Then, we integrate each of the items and we get the antiderivative becomes 3/50 times x power of 4 by over 4 minus 4 x power of 3 over 3 plus 5 x power of 2 over 2. So, from the expression, we substitute x equal to 5 into the expression Then from the expression, we multiply the expression before with 3/50, and then we simplify it, and the final answer will become 3.125. Okay, now let's talk about question B, which is we have to find the cumulative distribution function of a random variable x, which is fx. Okay, for fx equal to p, x is less than x is equal to integral of negative infinite to x ft dt. So if x is less than or equal to 0, then fx will become 0. If 0 is less than x and less than 5, then fx will equal to integral of 0 to x 3/50 times t squared minus 4t plus t dt. Next, if x is more than or equal to 5, then fx is equal to 1. So we have to calculate the integral for 0 is less than x and less than 5. Okay. Fx is equal to integral of 0 until x 3/50 times t squared minus 4t plus 5 dt. We remove the 3/50 to the outside, so it becomes fx equal to 3/50 integral by 0 until x t squared minus 4t plus 5 dt. Then we integrate the expression, and it will become fx equal to 3/50 times x power of 3/3 minus 4x squared over 2 plus 5x minus with 0. Then the answer from the expression is fx equal to x power of 3/50 minus 3x squared over 25 plus 3x over 10. So we conclude that fx is equal to 0, which is x is less than or equal to 0, for x power of 3/50 minus 3x squared over 25 plus 3x over 10 is 0 is less than x less than 5, and lastly we can conclude that x is equal than 5. Okay, next let's move on to the next question, which is question C. Using fx, we have to find the probability of x is more than 2.5. Okay, for fx more than 2.5 is equal to integral of 2.5 until 5, which is 3/50 x squared minus 4x plus 5 dx. So we take out the 3/50 to the outside, and it will become 3/50 integral of 2.5 until 5 is times by x squared minus 4x plus 5 dx. So we integrate the expression, and it will become 3/50 times x power of 3/3 minus 2x squared plus 5x. Then we substitute the value 5 and 2.5 into the expression, and the final answer we can get the fx is equal to 11/60. Okay, so this is the last question for set 2, which is question D. Using the fx, find the probability of 1 is less than x and less than 2.5. So fx is equal to probability 1 is less than x less than 2.5 is equal to integral of 1 until 2.5 3/50 times x squared minus 4x plus 5 dx. So we take out the 3/50 to the outside, and it will become fx is equal to 3/50 integral 1 to 2.5 times x squared minus 4x times plus 5 dx. Okay, now we integrate the expression, and it will become 3/50 times x power of 3/3 minus 2x squared plus 5x. Then we substitute the value 1 and 2.5 into the expression, and the final answer we can get fx is equal to 9 over 80.